Vector and matrix algebra 8. Expand each of the following expressions by explicitly writing out all the terms in the implied summations. Assume I, j, and k can each take on the values 1, 2, 3. First, we're going to do Kronecker delta ij epsilon ij k. So let's try Kronecker delta ij epsilon I, j, k. Kronecker delta tells us that unless I is equal to j, the answer is 0. So if I is equal to j, we will have epsilon iik, but we know that when two of the indices of the Levi-Civita symbol are equal, that means we will have 0. So our answer is 0 for this one. Okay, next one, Tij, Aj. Tij, Aj. This sounds like a matrix multiplied by a vector, and that means there will be a summation over the j index. So if I write when I is equal to 1, Tij, Aj, this means this is T11 A1 plus T12 A2 plus T13 A3. That's the first possibility. Next, we can have I is equal to 2, which means T2J Aj, and that also implies summation over j. So it is T21 A1, j is equal to 1, plus T22 A2 when j is equal to 2, plus T23 A3 when j is equal to 3. And for I is equal to 3, we will have T3J Aj, and that's equal to T31 A1 for j equals 1 plus T32 A2 for j is equal to 2 plus T33 A3 for j is equal to 3. And let's look at the last one, delta ij Tij Ai. Now this is Kronecker delta ij Tij Ai. Now this implies summation over j and summation over I. So let's take a look at this explicitly for different j values. So this would, for example, imply delta I1 Ti1 Ai plus delta I2 Ti2 A2 plus delta I3 Ti3 Ai. So this was I, not j, so this is Ai. Okay, so let's look at I is equal to 1 case explicitly. This will give us delta 11 T11 A1. All the rest will be 0 because I is not equal to j, and this means it's T11 A1 for I equals 1. For I equals 2, we will have delta 22 T2 A2, this term. The rest will be 0 because I is not equal to j, so this will give me T22 A2. And for I is equal to 3, this implies delta 33 T33A3 plus 0, which means it will be T33A3. So it's T11A1, T22A2, and T33A3. Okay, so we could also see this explicitly by saying I must be equal to J. That's what Kronecker delta is saying. Kronecker delta Ij is Tijai implies this is Tiiai, which means for I equals to 1, this is T11A1. For I equals 2, it's T22A2. And for I equals 3, this is T33A3. Okay. So as you can see, as we have seen explicitly here, the answer for I equals 1 is T11A1, for I equals 2 is T22A2, and for I equals 3 is T33A3. Okay, so we've looked at explicit expansions of these terms. So delta ij, epsilon ijk, that's epsilon iik, and when that's two indices are the same, that is going to be equal to 0. So this could be written explicitly, for example, for I equals 1, delta 1, 1, epsilon 1, 1, 1, for example, I, J, and K, they're all equal to 1, plus delta 1, 2, epsilon 1, 2, 1, etc. So all of these terms. And whenever you have the same indices in the epsilon, you will get a 0. So that means all of these terms will give you a 0. So they each give 0. Tijaj is T1jaj, which is T11A1 plus T12A2 plus T13A3. This J index is repeated twice, so that means there is an implied summation over the J index. And for depending on different values of I, we have different answers. So T2jaj or T3jaj, they give each different expansions. And for delta ij, Tijai, this implies it's Tiiai, which means it's T11A1 for I equals 1, T22A2 for I equals 2, and T33A3 for I is equal to 3. If we do this explicitly, this is going to be equal to delta I1 T1 AI plus delta I2 Ti2 AI and plus delta I3 Ti3 AI, because the implied summation is over the J index. That's the repeated index, repeated twice. And now if I substitute I is equal to 1 here, this gives me T11A1. If I substitute I equals 2, it gives me T22A2. And if I substitute I equals 3, it gives me T33A3. So the I index is repeated 3 times. That doesn't imply summation. So that's what we find out. The summation is implied if an index is repeated twice.